in this problem, we have a what is called golden triangle, ABC, isosceles triangle with angle A 36 degrees, and B and C, of course, is going to be 72 degrees. Now, we have a point P inside such that this angle here is 18 degrees and ABP is 30 degrees. We want to prove AP equal BC. Alright, so we're going to show the proof by considering that this golden triangle appears in the regular pentagon. Alright, so let's take a look. In this pentagon here, right, all sides equal, is regular. We notice that ABC has the property that this is 36 degrees, this is 72 degrees. Alright, so our problem can be proved by fitting a regular pentagon with ABC. Alright, so instead of considering the P, let's erase that. Let's construct another point Q in the following fashion. Right, so here we construct Q in the golden triangle ABC that is embedded in the regular pentagon. Here, this is a regular triangle. ADQ is regular. In other words, these three sides equal to each other. Of course, for the regular pentagon, all sides equal each other. AE or BC equal AD. Alright, also equal AQ. You know, here AQ equal BC. But we try to prove AP equal BC. So only if we can prove Q and P coincide at the same position, to the same point, right? Now, let's show that. So here, we have regular triangle here. We'll notice that ACD is another regular triangle. In other words, AC equals CD, isosceles triangle. This angle here is 36 degrees, and this is going to be 72 and 72. All right. So we claim that we have congruent triangle CDQ and CAQ. So why? Because this is side, this is isosceles triangle, and this angle here is 32 minus 60 degrees, 12 degrees, and here the same thing, 12 degrees. All right, side, angle, side. So these two triangles are congruent, and this angle would be identical here, congruent here. So in other words, CQ is the bisector of this ACD angle. Okay, CD is the bisector of ACD. What is ACD? 36 degrees. So what is ACQ? It's only half of that, is 18 degrees. All right, that's good. So only if we can prove ABQ is 30 degrees, then we know that P and Q is going to be the same point, right? How are we going to prove that? Now here, we notice that D has equal distance to A, Q, and B. Why? Because all the distance equal to the side of the pentagon here. AD equal DQ, right? Because this is how we construct a regular triangle here, and equal DB. So in other words, D, treat that as a center. We can draw a circle, and AQB is going to be on the perimeter of the circle. Okay, here. Now by looking at the vertex angle here, ABQ is going to be half of the inner angle here, ADQ. What is ADQ? It's 60 degrees. So in other words, ABQ equal half of ADQ, right? And then what is ADQ here? By construction is 60 degrees. So ABQ is 30 degrees. In other words, for Q, we have a property that this angle is 30 degrees, this angle here is 18 degrees, right? So we also know that because this is a regular triangle we constructed, so AQ equal BC. AQ equal BC. Okay. So now let's look at the original point P. Remember, P is such that this angle is 18 degrees, this angle is 30 degrees, all right, which coincide with our Q. In other words, AQ, we know that originally the point Q equal BC, right? But now we know that ABQ, ABP, ACQ equal ACP, right? So we claim that P and Q are the same position. Since AQ equal BC by construction, we know that AP must equal to BC. That's the proof. Okay? I hope you follow the steps, and please like and